Hello?
Hey, hello, Tony. Good evening. Welcome.
So I just want to be sure we are saying, maybe we are talking because I don't know.
Okay. Yeah, I was muted. Yeah, okay. So I was actually waiting for more people to join, but all right. Let's share screen. All right, guys, let's start. Okay, so we are doing okay. We are doing what are we doing today? Ansible. Ansible. Let's prepare our environment. I'm sure I deleted some of the stuff we had together because I use this place. Let's see what we have here. ls minus where this mean. This is PowerShell. Let's go to Ubuntu. I'm not sure which of these we need. Class demo project. We have many projects because I use this to teach DevOps class. So let me just ignore all of these. What do we need? I'm not even sure what we need. Let's just start. First of all, we need to set up, in order to start, we need to set up our servers. We'll configure. So let's go to Ansible. We actually started Ansible already. We configured server the last time, right? I think we did. Can you guys hear me?
Yes, we can hear you. We've set up the server, but we wanted to do the SSH connection, no, to connect the nodes with the controller nodes. That's where we stopped.
Okay, yeah. Let's do all of that. Let's do it as a full project. That will be this is the last topic for. Yeah, this is the last topic of the course. Okay, so let's just use it as a full project. We'll start everything from scratch. The CI/CD, just like we did the last time, but this time for Ansible. So for the full project, we'll need 3 servers for the Ansible, then 1 server for Jenkins. So for CI, Jenkins, for CD, 3. Altogether 4. Okay, let's set up 4 servers. We'll come back here. Where's my main dot here? Let me look for my main dot. Infrastructure. Main dot here. Count 4. All right. Control S. ls minus L.
Do we need 4 or 5?
Is it 5? 4 should do. 1 for Jenkins, 3 for Ansible. Yeah. The infrastructure, ls minus. Yeah. Okay, so Terraform init. We are building everything from Terraform. Okay, so let's say something. Okay. All right. We have our servers, Control C. And then let's save them somewhere. Notepad. Control V. And then let's prepare them for SSH. So this we'll do Control V. Control V. Control V. Control V. Control V. All right, so we're ready to start SSH. So let us start with this one, Control C, and then we'll go to PowerShell. All right, so we have one server. What do we call this one? Let's call this one controller. Control. So since we named it controller node, let us configure it for controller node. We'll go to the configuration for controller node, and then we'll run that. How do we configure controller node? controller node, we run the script. So let us do this. Control V, like we did before. Control V. Then we'll put the script there. Run the script. Only one data. Control C. Control V. Oh, we updated. We did something here the last time, right? We did something. What did we? User mode. This is not complete. We modified the last one.
We just added the bin batch, and that's what we did.
I thought we, after the installation, sudo apt install.
Yeah, it was
before,
that so we could stop using sudo
yes.
once we put in the docker. But it was it. We did it here too.
And then we restarted. We said doco. You know what? Let me just run it, and then if it doesn't work, I will come back and
Yeah.
yeah. So okay, so we have that. So now let us run the script. So copy that, Control C, and then we run it. Right? Let's just patiently do it one by one so we can follow. I could be running multiple server commands at the same time. This will take a while. Let me go and look for something here. And then let me do oh, okay. It's not showing there. Docker apps. Let's see how this one is going. Yeah, this was the part I was looking. Sudo, yeah, this was the part we added. Sudo. Okay, so Docker images. So the commands are not running. Docker, yes. All right, so it's not complete. So let's come back here. So what I should have there is just this. So I want to have this. install Docker. So Control C, and I should just replace. How come I have not noticed before? Just replace all of this. Control V. This is the normal way we've been installing Docker. All right. So just so we know that it's working, let's do this again. Okay, that'll take it. Yeah. So the part that is missing now is the app update. But let me do this last part. Let me do this. Do that now. Okay, so switch that back to Ubuntu, Docker images. Yes, it's working. So that's what it ought to do. So the part that we switch that back to Ubuntu, let me add it here. Let me switch that to Ubuntu. Our script has been improved. Right. So next time we run that, we'll get a package. By the way, let's just test that one. Our Python 3 was installed. All right, guys, so we have successfully installed the controller node. Ansible. And the machine in which we install Ansible will be the controller node. So this is the part that installed Ansible. And this is the part that installed Python 3, which is a dependent. All right, so that is fine. So on the other nodes, we simply go to the node 1 and node 2, and then we'll run this command. Right? Before we go to run this command, let's first of all connect to node 1 and node 2. We'll come back here, and then we'll call this nodes 1 and 2. And then this will be our controller node. All right, so let's connect to that. So Control C, and then PowerShell, and then Control V. All right, so that is done. So we want to call this one node 1. And all we do in node 1 is just run this command. You know what this command does? It simply install Docker. That's all. We install Docker. Now, while that one is going on, we can go back to PowerShell and then connect to node 2, Control C, and then we connected successfully. So we now rename this one node. Right? So okay. And then we run the same Docker. The same command to install Docker. Control C and then Control V. If we check here, let's see. How am I separating this? Why don't we just add this to the command so that we just copy everything? Yeah. So let's just add it to it. Okay. Right. So next time we'll just run them together as a single. For now that we didn't run them together, let's run them separately. We'll just copy this part, Control C, and then we'll it did not work. Okay. So switch user to Ubuntu. No, they cannot run together because I have to do that one. It will be switch user to Ubuntu. Password. What? No. What am I doing?
Well, we are Ubuntu already now.
Yes, we're in Ubuntu. Maybe this is not the system I should be. Control C. Yes, I think this is where I wanted to do. We'll come here and do. Yes, this is what I wanted to do. So we'll switch to that to Ubuntu. Then what did I want to check? I want to check Docker images. Docker images. Let's perfect that. Now it's not working. So, did we run this? Let's check. Do we already have what do we have? Docker in node 2. Docker minus. Yeah, Docker is installed. So Docker image do Docker image. So you can call Docker image do Docker image. Okay, so how do I separate them? So make that possible to run Docker, which is where's the pattern? This is the part that should have made that possible. Why is it not working? Not run it. Okay, let's run this again. You can see.
Well, we should do it as root. Then that's the way it works. We have to switch to root, then do the system.
Yeah, Consisto is right. That's what I explained to you. You have to switch back to root before, and then you run the restart.
Yes, that's right. So how come we didn't do that? So switch user to root. So we did that here, and then we worked as root to do that. So I expected that to continue. At what point did we now change to Ubuntu? So that one should have continued. Because here we already switched to. No, I can make it work right now, but I'm just trying to do this so that when you are copying and pasting, you don't have issues. Let's do this one more time. So let's do all of them together.
Can you check that you didn't modify this text now? I think you did.
Which one?
The second paragraph. The user modify ATS.
I just removed the sudo.
Okay.
I just removed the sudo because we already switched to root here according to your own vocabulary.
All right.
Control C. Let's try this again. Yeah, so that worked now. So it will be Docker image. Yes, so that's all. We'll have a perfect situation that works. That's good. So let's run that again. Control C for node 2 as well. But right now, we need to use sudo before Docker can work. So let's try that. Run that command. And then without using sudo, it's already giving us right? Without using sudo, if we say Docker images now, it works. Notice better than it. All right, guys. So we have our 3 servers. One configured as Ansible server, which will be called the controller node. The other two configured as Docker server, which we'll simply call node 1 and node 2. Now let's set up the SSH connection between Jenkins server. We don't even have Jenkins server. So our controller node will be picking the artifact from Jenkins server. So let us set up Jenkins server and set up a link between Jenkins server and the controller node from where the artifact will go into the controller node. All right, let's go and set up Jenkins. We'll come back here. And then we'll see Control C. And then we'll do SSH into this brand new server. And we'll do this. That is no, so let's call this engine. Again, right? What do we install to get our Jenkins? So let's quickly go and look for installation of Java, Maven, and Jenkins. If we go to hundreds of Jenkins. All right, so to install Jenkins, let's install Java, and then install Maven, and then install C, run Jenkins, and Maven. Then while that one is running, and that's what we can do is just put all of the commands together as a script. But only at this level. For beginners that do not even know how to do this, let's take it for all. All right, so for Maven, we'll run all of this. XP, yeah, complete that one. Let's install Maven. All right, so all of that for Java. Now Maven. Okay, so Maven is installed. Now let's go to Jenkins. So for Jenkins, I don't have it in the notes, so we'll go here. Go to the browser, Control V. We'll copy the command. And that doesn't work. So let me just see. And then okay, has that installed? Reading done. Sudo apt install Jenkins. Yeah. All right. So Jenkins is now installed. So go into Jenkins, we'll take the IP address. That report is default. See, is that Jenkins? Yes, let's just go to the then go to the browser. Right. Control C, Jenkins, sudo that, and then C. Right, so Jenkins is responsible for the continuous build of our artifact. And we have to create a road between the village and the town, or a pipeline between the rig and the tank, the reservoir where all of the oil will be gathered before finally the refinery. Admin, email. All right. Oh, yeah, we know that. We're using Jenkins. Right, so the first thing to set up our tools, we'll manage Jenkins. And then we'll see tool. We'll see Java. And then we'll go to Jenkins. We'll see Jenkins. Java UI. So for this, we don't do anything. For Melvin, we add my Melvin. We'll say install automatically. All right, with that, we are ready to start using it. Let's just install the popular plugins. We might need them. Maybe we need them, maybe we don't. Also, we don't. Available plugin. You remember the popular plugin? Warning. We'll install that. Build pipeline. So let's install available plugin. Build. All right. So this pipeline install. Which other plugin do we normally use? Okay. That's all right. So now we have our infrastructure in place. Let's start the configuration. So we said we needed Jenkins so that we would, we need one more plugin. There's a plugin for connecting servers together, SSH. Oh, before we even do that, before we get there, I'm sorry, let's follow the note. Jumping the gun. So let's follow step by step. So SSH, we already explained what SSH is and why we are doing it. So let's move now. Now that we have this Jenkins in place, let us move to the new. So at remote, right now we are talking in relative to the artifact. So for the artifact, Jenkins is the home of the artifact. Controller node is remote. We are discussing artifact. So for artifact transfer from Jenkins to controller node is the remote. So at remote, what do? We enter this command, and then we look for, we've done this many times, so let us go ahead. Where's remote? Controller node. So we come here, and then we do that. Then we look for password authentication. Then we change it to this, allow password authentication. All right, password authentication. All right, so that is done. What's the next thing? We'll restart SSH. Control C. We'll come here and we'll do that. And we'll set password for Ubuntu. So we'll sudo password for Ubuntu because it's going to ask us. And let's say daily from daily. That doesn't. Let's do it. Sudo password. Okay, so that one was. All right, so we are done there. We'll go back to the host, and then at the host, we'll see CD. We don't really need it. CD. Let's go to host. That was remote. To the host for this one will be this. Let's work from the Ubuntu directory, CD. Then we'll enter that command, which is generate SSH key. So you remember that. Yeah. Now the SSH key has been generated, private key and public. So now let us move the public key to the other machine that we want to be able to SSH into. In this case, what's the other machine? We want to be able to SSH from Jenkins to controller node. Let us go to controller node and send this public IP address to our controller node. All right, so Control C, and then Control. You are in the right place, right? Control B. Yes. What's the password there? Daily 2020. That was successful. The public key was transferred, was copied. And if you want to check, you can run this command. It says that you are now, that one server is now able to connect with the other server, and there is now SSH. All right, beautiful. We are making progress. Establish SSH connection between controller node and remote node. So we completed this first part. That one is beautiful. Now, once the artifact gets to controller node through the SSH road that we have just constructed, SSH node will also need to be, controller node will also need to be able to communicate remotely. That's why it's called configuration manager with all of the servers. For any communication like that to happen and for transfer to happen between them, we need SSH. Let us also set up SSH. Just like we did before, at the remote server, now we are standing at the controller node. We are no longer standing here. We are done with that. We are sitting here now. So once we are sitting here, this becomes the host, and these are now the remote. So at the remote server, which are the nodes, we run this command one by one, each of them. So Control C, we'll go to controller node 1. Node 1, not controller node. Go to node 1, yeah. And then we'll run that command that we did before. We look for allow password authentication. And then we run sit here with that SSH. Control C, Control V. And then we run sudo password Ubuntu. C, all right, password day 2024. Day 2024. All right. Okay, so that is good. We set up that for controller for node 1. So to complete that, add the controller, add the host, which is the controller node in this case, we generate the, last time we did this, we generated it in Jenkins, but now we are generating it in controller node. So completely, we'll go to controller node. We'll work from Ubuntu, and then we generate that. All right, so it's generated. So the public key, we send a copy to node 1. How do we send?
So we don't need to use the CD on this one because there's a CD in that on the manual.
Yes, because
On the
can you
boot.
see? Sorry? Do you see
Because
why
on
we
the
didn't?
manual. Okay.
Yes. Can you see why we did not need to enter CD? We're already in the place where the CD should take us to.
Well,
CD was to take us to wherever we are, it should take us to the tilde directory. So we're already in tilde. So that's why we did. All right. So yes. So let's send the public key. The command to send public key is ssh-copy-id Ubuntu. So where? Why are we sending the public key to this thing? We are sending it to node 1. So this is our node 1. This is the IP address of node 1. We'll put it to Control V. Control C. And then we'll come here and send to node 1. Make sure. Password for node 1, daily 2024. All right, so that worked. If we had already prepared node 2, we would have just gone ahead to do it for node 2, but we have not prepared, so it will not work. Let's try it anyway. Then we expect to get failure. If we come back here and say, do this same thing for node 2, then we say copy, Control C, Control V, Control C. We say, yes, we know that we have generated a key here. You sent one to node 1, sent one to node 2. If we put that there, and we'll say yes. It says enter Ubuntu for node. Did we create Ubuntu? We did not create it. We did not create a password. So I don't even know the. It's not even asking us for password. Sorry, it's saying permission denied. All right, so just like we expected, because we have not prepared the grant for that one. All right, so now let's go prepare the grant and then come back, and then it will no longer say permission denied to allow us. All right, so let's go to node 2 now and prepare. So what do we do in node 2? We go into the configuration file for SSH, and then we allow password authentication. So the command is right. So on the nodes, which is node 1 and node 2, we'll go in there, Control C. I allow password authentication. All right, so password authentication is allowed. We'll say sudo system restart control. Restart SSH. So we do that. And then what's the last command? We set our password. Sudo password for Ubuntu. Day 20. All right, so we have set the parameters right. Right, so we completed those three steps. Okay, so we already generated the SSH key now. It's once. We don't already generated that in the host. So we'll simply copy what we already have there because we did it before. So a copy to node 2. So that's how we have this command here. Control C. We'll copy to go to controller node and then we'll copy. Let me go back. Okay. This one is asking us for password. Daily 20. Okay, and this time it says it works. Last time it said permission denied. But this time it is. All right, so we have successfully set up SSH connection backward and forward from the controller node. All right, I assume that we have done that many times, so I just went through it fast. Was that okay? Did you understand what we did? Did you understand how we accomplished? Everybody understood that, right? This diagram we have implemented it. All right, that is the task. That's the real work. Once that one is done, you understand that, you don't have questions, then the rest is easy. The rest is easy. All right, let's continue with the rest. All right, so what do we want to do now? Let us copy the Jenkins server artifact, copy artifact from Jenkins server to controller node. Whatever I want to do, we do it manually and make sure everything is working before we automate. All right, it is during the manual process that we see what we forgot to configure, what is not working. Then once we see, we make all of the corrections, everything work, we'll now delete the manual process and replace with automated. All right, so let us copy artifact from Jenkins. We don't have any artifact now. So let's create an artifact in Jenkins. Let us go back to Jenkins and build just anything. DevOps basic. Let's build anything. All right, so we'll go to Jenkins, go to dashboard. We don't have any artifact, so let's maybe create a small project just for us to allow us to build artifact. Let's call it project 1, freestyle, and then let's just build a basic. We'll get what are the projects are we building? Let's build DevOps basic. So GitHub DevOps basics in private repository. Right, so we'll take that, Control C. We'll provide the link here, Control V. And then if this is private repository, I need access. Okay, let me create the username to get to this repository. And the password. Let me get that for the name. The password is right. This the ID, the item. Not care about this description. Right. So I say use that one. All right. It has access. And then build the master branch. What if you have many branches? And then to build, use Maven. Build step, use Maven. And then use my Maven, clean, install. Same thing as package. Yeah, let's do just that for now. Then we'll continue to do it. All right, so let's build. Can that generate artifact for us, or is there something that we forgot to install? That I will not make it work. Let's find out. All right, so that generated artifact for us. That was successful. And the artifact is saved where? Where do we find the artifact that we can copy? Let's come here. Building that wall is saved here. So if we go here, we'll find the artifact webapp.wall. So let's go there, Control C, and then we'll go to Jenkins. And then we'll clear the screen, and then we'll say, go to the place where the artifact is stored. And we are there now, ls-l. This is the artifact that we do. Right? So the note says, copy this artifact from here into controller node. Because right now in controller node, ls-l shows that there is nothing other than the file that we just use for our setup, which we are done with. So we can actually delete it. We don't need this anymore. It was just the raw material we use in the control. I mean, we don't need it anymore. So let's clean it up. That doesn't. How do we remove it from? Remove all files. ls-l. So there is nothing there. Okay. So to manually copy a file, it will be, of course, we can write it out, but I can just look at the note and just copy the command directly. S copy the file from source to destination. Right? So this is it. S copy the file, webapp.wall. We'll go to S copy this file, webapp.wall, to where? To the remote server, which is Ubuntu and the remote server. What's the remote server that we are copying to controller node? So let's go and get it. It will be Ubuntu at controller node. That is Control C, and then Control V. But when you get there, don't just dump it anywhere. You have to be in the particular place. So put colon and say put it in home. Ubuntu. This is the home directory. Right? /home/. So that's how come we have this command. Right? So if we do that and we do enter, webapp not a regular file, there's a problem. So the full name is webapp.wall. We wrote only one. Yeah. We'll complete the name. And then that work. It says I have copied the file for the home purpose. Last time we had controller node and we did ls-l, there was no file. But now the file has been copied. Oh, beautiful. So now we know that the link is working. By the time we go to automation now and it says it will not even have choice. It will not say anything. It will work. Okay. The link, if the SSH was not working, there's no way we would have copied it. All right. So what's the next thing we want to do? Next thing we want to do is convert this image, this artifact to image. To do that, we need another file called Docker file. So we'll create Docker file. di Docker file. Then we'll put this content inside Docker. Where's the content? So this one is saying, take a base image called Tomcat from Docker Hub, and then wrap this my artifact around that base image and come up with a new kind of image that I can run. Yeah. So that is what the Docker file is. So take the Docker file, Control C, put it in here, and now we have created that Docker. So if we do ls-l, we'll find these two files. These are the two files that we need to create an image. The artifact and Docker file. Right? So if we check Docker images right now in the controller node. There are no images. To build a new image from these two files, the command is docker build. Docker build. So we'll come here and we'll run the command. Okay. Okay, I forgot what we're talking about then. Okay. It's a bit different here. The method I was using was Docker. But since we are using Ansible now, Ansible is just a little different. Ansible is just a little different. All right. So for Ansible, instead of just going ahead to build and run as if we're running only Docker, for Ansible it's a little different. So for Ansible, we are going to need two additional files, the playbook and the host file. So we need to create these two files, playbook file and host file. All right, so playbook and host. So that is the difference. All right. So let us create these two files.
What is the playbook file and the host file?
Yes, that's what we're going to explain. So let's start with the host file. So the host file will contain all of the node IP addresses, all of the 30 nodes. 1, 2, 3, 4, 5, all of these nodes. In this case, only 3. In our own case, only 2. All of the remote nodes that will be deploying the app to, it will be contained in our inventory file. Another name for host is inventory, right? So that is what we'll have. So we're going to do in the controller node, where we'll have these two files, we are going to create two more files. We're going to do vi hosts. It means the IP addresses of all of our remote servers. In this case, we are going to copy. So host means inventories. So this is how to list it. Control C. Then we'll come here and put it. Right? So we're going to see all of the servers. If we want to refer to them together, we'll just call them web servers. Right? Anytime we say web servers, we're talking to all of the IP addresses here. And what are the nodes? We already have them listed. So let's just copy them from here. Our node 1 is this one. This is the IP address of node 1. Control C. Control V. And this is the IP address of node 2. Control C. Control V. If we have 30 of them, we'll list all 30 IP addresses. And then we'll copy them, Control C, and then we'll present them here as our list, the list of our hosts. All right, what did I do? All right. So it's also called inventory, which means the list of all our hosts. That's it. We have created a host. That's it. Very simple. So save. Okay. All right, so if we do ls minus l now, we have 3 files now. 3 files. Docker, host, web, app.1. Right? And then this here, so we have Docker file, hosts, web app.1. So remaining one more file that we need to create, the playbook.yaml. All right. Host. Is it important? But let's be consistent. I think host is a small letter H, not big letter. I think it. So let's move host to. So we have renamed it. ls minus l. Looks like we have changed the looks like we have. All right, so the final part now. Did you understand that? I think I should slow down. I mean, we've done all the part that we have done before. So let me slow down now on this new one. So do you understand the meaning of host and how we created the host file?
Yes, sir.
Okay, 5 or 4 something. All right. Now the last part, the playbook. Create an Ansible playbook. It's a YAML file. Is this the first time you are doing YAML? This is the first time you are hearing about YAML. Okay. It's another kind of automation tool that is commonly used in Kubernetes, but it's a different kind of script. All right, so this is a sample YAML file. So let's just copy this and then come back and explain. So copy this YAML file, Control C. In fact, we're not even sure that this YAML file is good. So let's go to this website. Then we'll go to Control V. Control V here. And then we'll put, we'll take that YAML file, and then we'll put it here and say, please, help us validate. Is this YAML file okay? Control C. To be honest, the validator is not perfect, but at least you can degree of accuracy help us know whether Control V. So it says it's a valid YAML. But if mistakenly we just introduce like space here, then we'll say validate. It is error. So the playbook, YAML files generally are very strong on indentation. That's about the only thing you get wrong, right? Make sure the indentation is perfect, just like we have it now. I've returned it to what version B. If I say validate YAML, it's still not okay. Go back almost there. What did I do? Is this okay now? Okay, I've messed it up. I'm just going to delete it and replace it with a new, and then say validate YAML. It says valid YAML. All right, so now that it says it's a valid YAML, let's go and make it work first, and then I'll come back here and explain it. Control C. And then I'll create VI Ansible playbook. And what name should I call it? I can call it any name, but for now, I'll just call it playbook.yaml or playbook1.yaml. Let's just call it playbook. So I'll come back here and do VI playbook1.yaml. YAML can be YAML or it can be YML. And then whatever I copied from there, I just put it here straight. That's how I've created my YAML. Now I have all 4 files that Ansible needs to create, to deploy the artifact. To convert the artifact into image, it needs Dockerfile and the web app. And then to go ahead and remotely host the resultant image, deploy the resultant image to all of the nodes. We need the host file, the list of IP addresses of the host. And then the instruction contains, the file that contains the instruction as to how to actually do the work is saved in playbook.yaml. All right, all 4 files are ready. So let us run the Ansible command that will do this and deploy to all of our 51 servers. That command is Ansible playbook -i host playbook.yaml. This playbook.yaml is the playbook.yaml one that we created. So I'm going to put it one.
Yeah. I still don't understand the playbook file.
Yes. Okay. So let's go to playbook. This is the playbook. So this is saying, this is the meaning of the playbook. When I say Facebook is talking now, not me. It says, when I say host, I mean all of the IP addresses listed. Why is it starting with that? You start with slash. I mean, hyphen. One part is missing. So hyphen means, let's quickly correct that. It means this is going to be a YAML file. That's the beginning of a YAML file, right? So hyphen, whatever is following now is a YAML file. Now I'm going to refer, anytime I refer to host, I am talking about all of the IP addresses listed in the host file. Not the first one, not the second one, not the third one, not part of it, everything. So all of this is the syntax for YAML file. This is how YAML files are written. Just copy and understand. All right. Now this part is saying, these are the tasks to accomplish. Number one task, there is a file named Docker file. Copy that Docker file into the remote machine using the command copy from source Docker file to destination current. Anywhere you see dot, it means the destination /home/Ubuntu. So this YAML file is copying the file, Docker file, from where? From Docker file here to the remote host. So in this case, it is copying Docker file from the current place, controller node, to this remote server. Everything listed on that host. If there are 31 of them, it will copy to all 31. If there are 50 of them, it will copy to all 50. Because we said host equals all. So instead of manually going to this place to copy these 4 files into this, go here, copy the 4 files into this, go here, copy the 4 files into this. We're just issuing a command from here to remotely copy Docker file to all of them. So that's the meaning of this statement. And already we can see, instead of scrolling up and down, let me go. You can see a mistake there. Let me do it from here. Let me correct that. I know I missed the hyphen. So let me correct it. Control C and then Control V. All right, so this is correct. Validate. So let's quickly correct. Otherwise, we'll talk and we'll forget. Let's do VI playbook. Let me do the that is not there. So do Control I. The long way to delete this manually. So let us delete it. There's DD to delete it line by line. Okay. All right, so I'll put a new, then I save this name. All right. All right, so like we were explaining before, so that is the part of that one. So what about this one? This one is the same thing. It's saying copy the file webapp.war to all remote nodes. All right. And then it says here, if there's already a container, if there's a container that is already running, stop that container. I don't know if you remember our previous experience, that once a container is running, I will try to to modify the operations of that container, it will not work. We'll have to stop the container and then remove the container and then remove the image. In other words, clear whatever is currently occupying the container and the machine before we can now create a new one and run a new one. So the Docker commands that we normally enter manually on system, we have entered all of the commands here so that this controller node will now deploy all of these commands in all of the 100 servers that are remotely connected to the controller node. So that is just the work of configuration management. Instead of us managing all the 100 servers one by one, like we did with Docker, then controller node should simply deploy the list of commands we have here in each of those. That's what it does. All right. So specifically for this command, it says copy the Docker file that you have here to the remote server, copy any file that ends with the extension here to the remote server. If on the remote server, any image is running, stop it. Any container is running, stop it, clear it, and then create a new image in the remote server, and then run the image in the remote. Remember the commands? Docker build, then Docker run. That is what the playbook is. Do you understand?
So is that the reason why we
Yes.
downloaded the, what's it called, Python 3 with Ansible?
We use that one to install Ansible.
Ansible, okay.
Because it is Ansible that is doing this work now. This work that we are giving, this is Ansible doing it.
Okay. Because when we're doing the IAC, when you do the Python, it uses YAML too. So that's just why I'm asking.
When you do Python, it uses YAML?
Yeah. When we IAC, when we use the Python code to run infrastructure, it uses YAML.
Okay. Okay, you are saying that, yeah. So YAML is really common for scripting, for building stuff. You see more, the whole Kubernetes, as big as it is, it uses YAML file, yeah. So, like you can see now, Ansible also uses YAML. And then maybe your question was, okay, now you understand why Ansible uses YAML since it is dependent on Python, which you already know uses YAML. Oh, that must be a relationship. Yeah. So what does the playbook do now from what we have explained? The file playbook.yaml, what does it do?
Helps us automate the process, because before now, normally we would delete all those files, stop the process, stop the image, delete the image and the container manually. It helps us automate that. We had that issue when we were sending the files to manual.
Perfect. Perfect explanation. Perfect explanation. So since we are not going to those remote machines one by one to be doing it manually, so this helps us automate them. Exactly. So all of the commands that we should be typing there manually, we'll put them all here, but not as a shell script, not as a Terraform script, not as anything else, as YAML. So that's the method is used to. That is the style is used. Because like somebody observed, it is built on Python technology or Python environment. And since Python uses YAML for its own infrastructure provisioning, then it makes sense that Ansible should be independent of YAML. Of Python should also use YAML. Beautiful. Perfect explanation. All right, so that's it. What about the host file? The host dot, no, it's just host, not dot anything. What does the host file do?
That one lists the website from the node website, or the nodes website that is going to connect into.
It lists what?
The nodes websites, the IP address.
Yes, nodes IP addresses, not IP address. All right, that contains the list of all IP addresses to which controller node will deploy the application, following the instructions in the YAML, in the playbook.yaml. Correct. All right, so now you understand that, right? So can we move on? All right, so now that you understand the place of everything and you have assembled all of the 4 files that we need, the command to make it happen is Ansible playbook -i host, then the name of your YAML. So in this case, this is our command, Control-C. If we go here to controller node, remember we're not doing anything directly in any of the remote nodes. The work of controller node is to help us deploy to these remote places. That's why it's called configuration management. All right, so we run the command here. First of all, we have to ensure that all our 4 files are there. I always like to see them to say there. Hey, there's a mistake. Here we are calling, in fact, let's pretend that we don't know. Let's run the command. So this is the command. So the commands are running. It's deploying to all files. So look at error. It says in the command, in the playbook, you said, where is the command? You said copy Docker file, right? So it says an exception occurred during task execution. To see full traceback, we do this, blah, 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 right? We could not find or access the file, Docker file that you refer to. So here we said, go and copy Docker file. Look at the Docker file. But do we have Docker file there? We don't have Docker file here. The Docker file we have here is big D, capital letter D. And we are saying, go and copy small letter d. Small letter d, Linux is case sensitive. So let's correct that. They said that we make this one small letter d, or we'll correct, we'll just be consistent, or we'll correct what we have in the YAML. YAML has many entrants, D. Instead of correcting here, correcting there, maybe we just change the name of this one to small letter. So let's change that name. Because we said copy small letter Docker, and then we don't have small letter Docker. All right, so that's an error, so it will not run. So let's correct that error. ls-l, rename, oh, not rename, move Docker file to Docker ls-l. We have now renamed the file to something it can find. All right. So now let's run the command again. And that's corrected that error. It's gathering fast. We found a list of IP addresses, 2 of them, and then there was no running container to stop, but it said error and continuous. No running image to stop. There was no image to remove. And then create image for these 2 remote servers, and created run for the 2 remote servers and everything. Now it has connected, everything is okay. So 8, okay, 8, changes 7, and servers that were unreachable 0, number of failures 0, number skipped 0, number ignored 3. So yes, everything is fine. It's been executed. So if we now go to any of these nodes, we are going to find that the applications are already running there. Right? Even if we don't, okay, let's take it step by. So for example, let's go to node 1. I'll say node 1, I did not come to you, I did not do anything, but do you have any processes running? Docker PS. Okay, process is running. Okay, process running, and you can access the process through port 88. Right? So what about node 2? Docker PS on node 2, the same, right? We didn't go there, we remotely deploy from controller node. And then since we can access the process through port 8080, let us see what is there. If we come here to the node, And then we say true port, PHP. Let's see that application. All right, the same application you are used to that we deployed before, the web app. No, not .1, just web app. All right, so this is our application simultaneously deployed to all the servers listed. All right, guys, that was Ansible.
Is our controller node also hosting an application?
Right now, no, but you can make it host an application. Yeah, you have it before. Yeah, right now it's just the truth. It's just the truth.
But if you were to host an application, then would it be different? Would you list it in the host, the inventory?
Yes, that is the only additional thing you need to do. Just list it in the inventory.
Okay.
You already have the Docker that will enable application. So good question and good effort. All right, so that was a manual process, which did it successfully manually. Now we have the confidence. So just to remind you, we created a playbook.yaml, we created host, we created Docker file, we created playbook.yaml, we created host, we created Docker file, we copied our web app.1 file to that page, we set up our SS. In fact, we did all of this first. We did this first. Control B, Control B, Control B. And then we just tested our deployment and everything. All right, so that's fine. So let's go and automate the process. Automation is what we are being employed to do, not this. Right, so let's clear everything that we already did. So if we take this command, Control C, and then we'll run it from our controller node. Controller node will clear everything in the remote. If we come here now, and then we'll run that command. Clear everything. So if we go back to node 1 now and do Docker PS like we did before, there's nothing running there anymore. We go back to node 2, node 2, and we do Docker PS like we did before, nothing there anymore. Because controller node is able to remotely configure all of them. And it just did that with this command. And we cleared everything. All right, now that we have nothing running, let us now automate the system. When it comes to automation, it's always about Jenkins. So let's go to Jenkins. If we refresh this one and nothing is running because we cleared the image that was there before. So let's go to Jenkins and complete our automation. And then we'll now do our CI/CD. We'll see the end-to-end. All right. All right, to automate, we go to Jenkins. And then we set up our publish over SSH plugin. We did this for Docker before, Lariana. Let's do it now. So let's go to Jenkins. We don't need it. Welcome to dashboard. Admin. Let's work on this project. Before we continue, let's quickly set up that plugin for remote SSH. Manage plugins. Available plugins. Publish over SSH. Publish over. Okay. So we'll install this plugin. All right, so that plugin is installed now. Go back to managing. We'll go to system. Then we'll go to publish over SSH. Publish over SSH. Then we'll add the server to publish to. We add SSH server. This time we're adding a controller node. What's the host name? It's always the IP address. What's the IP address of the controller node? Controller node, this is network. Control C. And then we'll come here and we'll do something. And then the username is Ubuntu. What's the directory Ubuntu can work on? Current directory. Avoid sending files that do not. That's very important. If we test connection now between these two, if we apply, and then we'll test the connection, it's going to fail because we did not provide the password. So let's look for password. We go to advanced. I'll see Ubuntu password is daily 2024 hash to access the. All right, so if we now test connection, this time we should pass because we have provided username and password and correct IP address. Where is the place to test? Okay, here, test configuration, and it's fine. All right, that's beautiful. We have successfully set up our SSH connection from Jenkins to controller. What's the next thing now? Let us build a new artifact. We'll go back there now. And then we'll say, we're not introducing anything. No, it's not time to build yet because we are going to introduce anything. Build a new freestyle project from the last working one. Then edit Docker command to carry Ansible command and don't build. Right? So if we build now, there is nothing new we are doing. So let us edit or build a new one. Let's edit it. So this time we say, yes, go ahead and build like you did before. But this time, after building, post-build action. After building, publish over SSH. Set build artifact over, send build artifact over, send it to controller node, and the name of the build artifact is web app.work, and you'll find it inside the web app /r. Okay. All right, and then remove all of this. Control C, Control V. Remote directory is always in the working directory and current directory, right? For now, don't execute any command. Just transfer the build artifact to controller node. That's it. Okay. So we'll apply. Let's try that. Let's test that. We don't just build the whole, we build layer by layer, and then so that we know where there's error, and then we'll correct before we put another layer. So let's see if this works. So the build number 1 was basic, that worked. Now build number 2, where it has to create and send. Let's see if that works. Oh, that worked because it says I built it and 1 file was transferred, right? So this time, 1 file was transferred. Let's show you some. All right, so host, copy this file, copy that file, stop running container, remove the running container, name, remove the running image, create a new custom image, and then create and run a new container. So because as part of the errors we ran into earlier on, so as part of the command, it is now able to stop and delete containers by itself without waiting for us to come and do it. So the idea of, first of all, going to manually delete is no longer there because that we have now automated that. So if we now go to controller node, all right, where's controller node? Yeah, and then we'll do ls minus l. Right, so whether we have this one here or we don't have it, a new one would always stop. So you see one problem that Ansible has solved for that we used to have with Docker. All right, so what's the final thing? Now that we see that our S copy is no longer necessary because we are now able to copy it. After we copy this file successfully to controller node, what should controller node do with the file? You can tell me. Yeah, the web app.war was successfully copied to controller node. Now it is here. What's the next thing that controller node should do now?
It will build. It will build and run the.
Yes, correct. To build the new image and then run the new image in the remote servers as application. So what are the commands that the commands are already here actually? The commands are already here. So what am I asking? The commands are already in here. So we don't really need to. What does the note say? So the note says, don't put anything there. Yeah. And then we copy that here. Yeah, there's nothing to do, to be honest. The commands are already there. So all we do is just put this command in this is the only command we should run on our terminal. And that's the same command, Control C, that we are taking to go and put in here. That's what we would have completed it. So we take that final command, then we go to Jenkins, and then we improve on what we have done so far. Go to computer. And then we come to execute, and then we'll put this final command. All right. So once we run this command, Ansible playbook, all of the other commands that you should be executing, they're already inside. Let's do it now and see whether that works. So let's build. Let's do build 3. Build 3. Unstable. What's the problem? Send build artifact over SSH did not work. Except send build artifact over SSH change 5 to unstable. You're supposed to be able to delete whatever is existing. Okay, maybe let's do it only the first time. Or it's supposed to solve this problem. Why is it not solving? It's supposed to be. Let's just help it only the first time, this time. And then if it repeats itself, then we'll go and look for solution. So let us delete this file so that it can send it. So let's remove web app.work. We're supposed to remove it. Maybe there's something I missed. All right, so ls -l. It's no longer there now. So, okay, so let's repeat the command. Now let's go back to project and do build again. Build number 4. Build number 4 is happening. Still unstable? Okay, there's a problem. Let's find out what the problem is. Let's find out. All right, so connecting to.
Let's check the executive command that we put there just now.
Okay, let's check. So let's go back to project and then configure and then execute. Ansible play. Oh, it's a wrong file. It's called playbook1.
Playbook 1.
Playbook. Yeah.
Playbook 1.
Yeah, thank you. Control S. No, not Control S. No, I just say it here. All right. Thank you for that observation. So now let's do it again. Build. It's good to run into a problem occasionally, not everything you just run smoothly. But I see what we are doing. So I should have seen that. Maybe I should have been patient in reading the. If I was more patient and I read it word for word, I should have been able to see what the error was. I was rushing through because I thought I knew it. All right. So with that correction, everything is successful. It wasn't that the web app was there. That was it. All right. So if we come to controller node now, we are going to see that the last time we ran it said there was no process, but if we run it now, we're going to see there's a process. And to answer your question about can we also run it in a controller node, let's try. Let's do it. So let's add the controller node's IP address. Actually, we don't really need the IP address. All we just need to add to the host, we go to controller node, and then we do VI hosts, and then we'll come here and we'll say and we'll say run it in yourself as well. So we just put local host. That's how to say run it in yourself, even though you are running it in yourself. So let's try that. So now if we go to controller node and we ask, is there any process you are running here? It tells us no process. Okay, let's run it one more time now, just to answer that question. We'll go back here to project 1, and then we'll build number 6. We'll build number 6. This time we added one more host, local. Something is wrong. Controller node. When publishing, execute use artifact change. Is that the way to enter localhost? Maybe I should have put it in bracket. Let's configure. I'm not sure that's the way to enter localhost. Let me try that. And VI. Okay, let me ask ChatGPT. VI. Let me ask ChatGPT already. Oh, I have one server 2 times. No, not 2 times. Okay. Let's see. Okay, see, why is it showing me? Let's go to ChatGPT and do Control V. Why do I have that 2 times? What do you think, ChatGPT? Looks like you've provided a list under the local host. This will be configuration file or local host typically refers to the current machine. Yeah. And you correct the code. Yeah. I've not done anything different. It's the same thing. Is it because it was repeated? Let's try. No, how come I'm having? Okay, so in fact, I'm going to delete it. It's not repeated now. Why is it showing me? It looks good. But in any case, there's no difference between this and what I had, but let me just localhost, yeah. Okay, so Control S. So I'll run the command again. So let's go back to Jenkins. And then I've not made any change. I just run, just build now. Unstable. What is causing this? Build artifact over accesses. Okay, let's try. Connecting configuration component. Okay, let me go to controller node. Docker. Yes. All right, so ls-l, remove web app.wall, ls-l. Okay, let's try again. One step, project 1, build one more time. Okay, that was not the problem. Okay, let me remove, maybe there's something, one more thing I should do. I'm forgetting, I don't remember.
Let's try removing the local host.
Let's remove that one, see. So it will be VI host. And then I'll remove the local host. And then
maybe we should have tried putting it in that bracket. It doesn't.
Try putting it where?
So we would have tried putting it in that bracket, just like the web servers. But I mean, ChatGPT gave us the same thing, so it shouldn't necessarily be an issue.
All right, so that is it. So let's come back here and do a new one. Now we know whether that's really place the error could have come. Okay. All right, so I've used that too many times. All right, so I'll find out how to do that. We didn't do that way. So maybe localhost should be inside of that.
Can we try the IP address directly?
Yes, that should work, but yes, we can try that. That should work. But the normal thing is to put localhost. I mean, that's more common. All right, let's go on. And then I'll find out what that problem is, and then I'll share with you. Now, let us do our CI/CD. To complete our CI/CD, all we need to do now is add what? Webhook, that's all. Once we add webhook, again, we change the, we're not taking break because we'll be able to finish everything in another 20 minutes. Then we'll change we do the end-to-end by changing the code and see whether it is deployed automatically in the remote. All right, so let's do webhook. We'll come here. So, first of all, we'll come here. You can see that was deployed. So if we come to GitHub, then we'll come here and we'll say settings, then webhook. We already have one before, so we'll just edit it. Okay, so we'll just edit this to the new IP address of our banking server. And this is the new IP address. Okay, C, and then we'll provide that. Okay. All right, and then we'll see update. Then we'll go to Jenkins and see for this project, use webhook. We'll come here and we'll see use webhook. All right, let's see. Okay, now, we don't have the codes locally. Let's go and clone the code locally, and then so that we can edit. We'll go to our WSL, cd.ls-l. We have it here. So I'm going to say, you know what? I'm going to remove everything here. Well, this is not the time to be removing all this. Let me just create our own here. Let's make directory, or let's clone let's do git clone. What is the repo that you want to have locally and to modify? Let's look for that repo. This one, DevOps basic, and this is it. So let's clone this so that we can do code modification. All right, so we'll come back here and we'll say git clone that. What we call
it has been cloned already. It's already up there. I think so.
DevOps basics.
It's there.
It's on
It's on the local server here.
I don't want to use that one. Let's delete that. Let's create a new. Remove DevOps basics. Remove recursive. Remove RF. All right. So let's clone a new one. All right. So theITern. Then password. Okay. And C. And then Control V. All right. Okay, so that's fine. So let's make a modification here now, and then let's see if it refers there. So this is it, DevOps basis. And then let's go to web app.org. Let's go to source. Let's go to index.jsp. And let's change something here. Just like we did previously. This is the header. Where did we change the one that reflects? Welcome to. Let's do. Yes. This is the end to end CICDI project. All right, so we save that and then we push. That push should trigger the entire pipeline so that we just see the effects of our change in the node right away without touching it. So git status shows that I'm in the right place. So cd DevOps basis ls minus l. All right, so git status shows that the modification to that water Kubernetes. So git add, git commit minus m. Well, it's a final push. And then git right? The ITern and then password will be Ctrl+C and then Ctrl+V. All right, so if we go to, let us follow the path. We'll go to Jenkins now, and then we'll refresh this. You should see that something happened a moment ago. Yeah, it's happening now. So that one. What about Jenkins? Did anything trigger Jenkins? You see that triggered a new build. Okay, so the CI is working, the CD is working. I mean, this is still the CI. So the CI is doing a new build, and the new build was successful, beautiful. So it has handed over to CD. So CD is the controller node, and this one, there's no graphics to see what is happening in the background, other than to simply go to one of the nodes and check. Yeah, actually there is. We can go there and check controller node 1. Did you see anything recently within the last few seconds? And it says, yes, 40 seconds ago, controller node put something to me and I can see and I'm, so the CI/CD works perfect. And now for doubting Thomases that are not engineer, they just want to see all of this effect of this grammar. And so they come here and they change the refresh to see whether this one will change from welcome to home page to what we changed it to. And then it changed. All right, so our CI/CD end-to-end completed. Just like it did with Docker, but this time we are now also seeing it deployed simultaneously to multiple servers. We go to Node 2, and then we browse Node 2, is the same. So what's the IP address for Node 2? It will be this one, and through the same ports. It's exactly the same. Ctrl+C, and then for Node 2, all right. And then web. All right. Yes, this is the end of. This is the end-to-end CI/CD pipeline. All right. So that's what that. That's our Ansible one. And then, okay. And we still have work to do. We'll just take a break and then we'll come back and look at it. Any questions so far? So did you understand that? The end-to-end means from code change all the way to production. Everything has already been automated. So once you change code, you don't have to do anything else other than just watch the changes reflect into it. All right. So our CI/CD was fully automated and we have just tracked. We'll come back and we'll look at just some additional commands around Ansible modules, maybe 3, 4, 5 commands. And that will be already we've completed all of these projects. Nothing more to do. All right, let's go on a 15 minutes break, then come back on. We come here and do local 15 minutes. All right, welcome back. Okay. So, yes, we're going to look at the additional module command. Yeah, Ansible module. All right, are you there? Can you see my screen?
You can see it, sir.
Okay. All right, so let's go back to control. Any questions so far? Are you clear with everything? Yeah, because we're coming to the end now. There may be no need for class next on Wednesday. Maybe I just let you run your own articles and then post whatever issue you have so that I can support you. Just,
So I don't know. I think I would have preferred maybe we'll do a project on Wednesday. You come up with something, give us time in class, and we'll try to do it.
no, it doesn't work like that. You have enough projects. Look at all of these projects. Have you finished them all? Everything we've done in class. What other projects have you given? Yeah. So do repeat everything we have done in class. Like I suspect that many of you, if not all of you, have been doing. So, but the way for me to really, maybe that is old school. But usually you don't get everything. Even me, that teaches, even for somebody who teaches these things regularly, there are still challenges you come across occasionally. So I expect that you should run, if you practice hard enough, you should run into issues and then bring them to class and then we share them and then, oh, okay, that one is true. And even it should even be so challenging that we take off time to go and research and come back with it. So the projects are for you to repeat everything we have done, know them. No interview can be as hard as everything you have learned. No interview can be that hard. If you know everything, then you are ready for, as far as what we have covered is concerned, you are ready for that aspect of it. For example, you build all of these 4 files on your own, and then you run this command, and then you get results. Or you run it first time, second time, third time, you run into errors, and then you share the error, and maybe on your own altogether, we're not able to navigate the error, and then you don't get it. Those are the skills. That's where you build.
Can you change that playbook to playbook 1 so that it won't be any problem again?
Okay. For your class, it's playbook 1, but for a different class, it might be something. Yeah. Is that what you mean?
Yes, sir.
This one is already playbook 1. So let me save that. All right. Then on top of that, we've already completed all of this. So project 1, project 2, project 3, and now we are doing a configuration management. That's project 3. So you complete all of this, and then you are ready for interview. Ready for interview. Yeah.
I'm being curious about something here. When we studied the Jenkins server, we did what is called master-slave relationship. So is that possible in the industry standard for us to have a master-slave relationship with the Ansible controller nodes and the nodes also?
Ansible controller node, the node. Okay, for you to have Jenkins, yes. Okay, what you're asking is
then with the Ansible controller node, how would that be? How would that picture be? Can you just maybe you can put the light on that?
Yeah, so even if you have 18 Jenkins controller node relationship on one hand, and then you have your controller node 1. Your only concern with all of the 18 is in which of those servers was your artifact built. That is the one you are concerned about. You didn't get it?
I didn't get it, but maybe I didn't state the questions right.
Yeah, I understand your question, and there's no need for too much.
Okay.
So, paint. So your question is, if you have multiple Jenkins servers in this Jenkins master server configuration, maybe you have 4 Jenkins servers, where one is the master and the other ones are slaves, and therefore they are connected in that relationship. And now we are talking about Ansible controller node, and then we are talking about multiple nodes. And we have this relationship. So you are saying amongst all of these, how do we know the correct Jenkins to connect to? How do we connect all of this to the controller node? Which of them is confusing? Now we have 1, 2, 3, 4. So I'm saying, don't worry about, the only one to really worry about and work with is the one where your artifact, your .war is. .war is created in only one of them. This one is probably created for you to deploy your PMD. All of your what other log analysis might be there, and this one for something else. This one where you have your .war is the one that you should connect to, like we did here. So you will not concern yourself with all of this. And usually it will be the master, because it is only the master that has the Jenkins itself. All of this one, they don't run Jenkins. No, this is not the one. Let's call this one the one. You know this Jenkins interface that we are working with here? See this Jenkins interface? Are you seeing my screen?
Yes, sir.
This is present only on the master. The slaves do not have Jenkins interface. Just like our Ansible is present only in the controller node. This one, we have no Ansible installed. What we have installed here is Docker. What we have installed here is Docker. What we have installed, no Ansible, no Ansible, no Ansible. So in the same case, if you have master slave Jenkins configuration, you are connecting only with the one that actually has the Jenkins, not with the other one. So in other words, your master, your artifact should normally be deployed within the master. So the confusion of which one should I connect to from here should not arise, because there is only one. Was that not your question?
That's my question.
Mm-hmm. So was it clear now?
Yeah, it's clear now.
All right. It's just the concept. Once you get the concept right now, like you asked, you just say that, oh, whatever was cloudy will just become clear. Oh, okay. All right. So what were we going to do? Yes. Yeah, I think we'll emphasize that. This is just overview, introduction to, it's a course we'll have in future for a different, but I just felt I should introduce you to what, when they say DevSecOps, what exactly do they have in mind? When somebody's asking about DevSecOps, what do they have in mind? I just brought this really part of. Okay. All right, and then of course, like I normally do, before we go to this level of just copying and pasting everything is working fine, we run into issues. So in your own experiment, in your own learning as well, you may be running into some of these issues and you are wondering. If you just take your time to look at all of this, you never know when you would need them. They are just troubleshooting tools. So they are just extra notes, depending on what you run into, you might find the solution. They are just useful tips. But we'll no longer run into all of these problems because we practice enough and enough. And so many times we don't run into them. All right, so what we are going to look at now is very simple actually. No big. We've done the real project. Ansible modules. We are just saying that outside what we have done, it's also possible to run additional modules. For example, you can stay in your Ansible controller node and run the command localhost. Was that not how we spell localhost? dot that. What does it do? It will check, it will ping. Ping means check my connection with the other systems. Let's do it. Let's not talk about it. But before we do it, you know the host that we created earlier on? Ansible is not going to use that to do localhost. Ansible is going to go to this directory called Ansible. So let's go there. Where's the controller node? This is the controller node where Ansible is installed. If we do ls-l, we do cd root etc ls-l, you remember your Linux? cd ansible ls-l. So this is the Ansible directory where Ansible would, first of all, primarily look for its own configuration file and the host. So there's host here, and yet we created our own host. Why didn't we just use this one? Well, Ansible would always look for host here before looking elsewhere. So this is the host that you use. So to say cast host or vi host, this is the host. This is what the host should look like. All right. But here you see that everything here is comment. That's with hash. So it's just potential commands. So for you to make it a command, you just remove the hash there, and it changes from being comment to being a command. For example, if you have multiple hosts following a pattern, you can specify them like this. Okay. You have database servers put them, but what we have is web server. So we can put either their IP addresses, like we have in our own case, or for more advanced cases, you can use their website addresses. But we are using this is our common. All right. What I'm just going to do now, since I will like to have access to the format for configuration in case I want to use them, I'm just going to copy. I'm just going to use this one. So I'm going to do I, and then I'm going to edit this. I'll change this to command. Then I will remove this. I will just, or better still, I'll just leave those ones. Then I'll just copy my own IP addresses from my host. Where is it? Yeah. And then, where are my hosts? Okay. And then I'll just put them. Exactly what we had there. All right. I could have deleted everything and just put exactly what we have there, but let me just leave this format because we never know. In future, we may want to remove one of them and change it to common. So this one is it. So I'll just say save. Yeah. Okay. Okay. No, what did I do? Escape, colon, save quit. Can't open file. Okay. So control quit. Colon, colon, quit. So to edit any configuration file, I should do cd. All right, and then I'll go to okay. Bear with me. file already exists. O for read only, E for edit. It's simple now. Maybe I just delete everything and just put it. Then I put what I copied earlier. All right, so I escape and then save and copy. All right, so that is done. So the reason we did that is because this is where Ansible commands will be looking for host every time you say go and work with you. We have edited the host here now with the list of our hosts. Now let's run commands. The commands are not called commands, they are called modules. Ansible module. What's an example of module? This one. Let's see. What does that mean? Ctrl-C, Ctrl-V. Ansible localhost -m ping. What does it mean? It means ping the localhost, ping yourself. Are you seeing yourself? And when you see the command, ping pong, it means yes, I am seeing myself. Maybe wondering, this is actually like troubleshooting, networking. Why are you checking if I'm seeing myself? Why would I not see myself? But in networking, it's not like that. So the system may not see itself. And therefore, like when we try to deploy localhost the other time I didn't work, this is one simple troubleshooting we have tested to see, is there an interface to yourself that you are using to see yourself and connect to yourself? Ping pong. Oh, you are seeing yourself. Okay, at least. So what's the problem? At least it's one, usually the first phase of troubleshooting for us to know what is that. And then the next thing we want to do is this local host, is it communicating? Is it seeing the other nodes? And the command to do that will be Ansible connect with the other nodes that we labeled as web server. Ping them. Pinging is the command to test connectivity with servers. And -m simply means module, Ansible module. Ansible module means that they are Python commands already typed and saved in module form. All you just do is call the command and it will do its work. So in this case, the module is ping. If we call the module ping, then Ansible will use it to test all the IP addresses listed under web server to see if there is connectivity. It's just for troubleshooting, not really for you. Networking people use. Let's try that. So the idea is for you to know, to see, and to feel that, oh, when we say Ansible can connect remotely and configure systems remotely, oh, this is what we mean. This is how it does. Oh, okay. All right, so if we come back here and we enter that command, what do we have? You see, it's connected with all of the IP addresses listed under web server. In this case, there were just two. So with these IP addresses, it was able to ping successfully and it connected to say ping on. And then it tried the next one. That's the IP address success. Ansible tried to connect and it connected successfully. Ping pong. Right? So ping pong is good response from the system that you tried on. It's just like when you try ping in your regular maybe command prompt. I don't even have another ITN. Let's say I try to my command prompt. I try to ping dot let's say 8.8.8. Right? What I'm getting here is a reply, which means my system is able to connect to this DNS server. There is connectivity. In fact, it's a common way for testing your connectivity to the internet. So instead of reply here that I'm getting here, which means there is connection to the internet, what I'm getting there is ping pong. So reply here means the same thing as ping pong there. All right. Again, it's not for your use, it's just for testing. What other commands can we possibly use with Ansible? Ansible localhost web server IP address one. So this is used to ping selected IP addresses. If we're talking about 18 different servers, you don't want to ping all 18 servers at once or 70 servers. You can select the one that you want to ping. You can take IP address of one server, IP address of another server, and see if you're able to connect to them. So this way, I'm testing 4 different systems instead of pinging all 80 systems or all 80 servers listed under web servers. All right. What does this mean? Ansible web servers command. What does this mean? It means ls-la for all of the servers listed under web server. Instead of going to each of them one by one to do ls-la, I'll just use this command to do ls-la for them. So I come here, I'll make plenty of space for this, and I enter that command. All right. So you see the reason we label them web servers. All right. So if we press LA, we could check. There are only 2 here, but if there were 40 of them, it will do this one 40 times for each of the server. Server 1, node 1, node 2, node 3, node 17, node 23, node 40. Right. Without going into the nodes one by one, I stay on my Ansible controller and I'm able to manage using the module, Ansible module. Ansible module. All right. So if you claim at interviews that you know about Ansible, then definitely there'll be questions around what Ansible modules you know. You can run your regular Linux commands as modules. If you just run it as Linux by typing, no, it's not a Linux interface, so it won't work. You have to run it as modules. Okay. All right. Try 2 or 3 more commands. So if I didn't want to try for all of the servers, I wanted to do that for a particular server. Our Asia server, I'm trying to work on, not on all of the servers. So I just get the IP address for our Asia server, and I work on that one specifically. Then it's all right. So web servers disk usage. This is a Linux command that tells us gives us information about disk, about the storage for that system. Disk. So let's see what that is. If I come here and I do that for all of the nodes listed under web server, it's going to give me this storage information about each of them. So for this one, it tells me, it's not really about the details. This for Linux Systems Engineer, right? So they can say, oh, there's not so much space here. We need to add more space, or we need to whatever they need to do. It's not really for DevOps Engineer. Or even DevOps Engineer can use this to say, this system has only 7 gig of space, and out of that one, we have used how much space do we have left? 33% of space used. Okay, there's 60. You can monitor from here to see. You don't just wait for the system to run out of storage before you alert the networking people or the storage people. You can, 77% of our our storage is used. We will need additional space. You can leave a note, or you can leave a ticket to let the support people know that you need space for this new application. Maybe the new application you want to deploy to this remote server requires more space than is available. You can use this one to all right, and then Ansible sudo Docker processes. So instead of me manually going to each of those nodes like I did earlier on, ideally I should just stay in my controller node without going into any of those nodes at all, and run whatever command I should have run in the nodes. I'll run it from the controller node. For example, I can use this command to find out from my controller node without going to any of those nodes what is going on, what processes are going on in the node. So if I enter that command, it tells me on node 1, this is the process that is going on there. There's a process run. On node 2, this is the process. on node 3, and so on and so forth. Waited 43 minutes instead of me going into them one by one. Now you have a clearer understanding of the term configuration management. It simply means configuring and remotely managing all of the nodes without necessarily going into them one by one. You configure them, you manage them from just one central place. You can manage them all. That central place is your controller node. And what makes that possible is an application called Ansible, a tool called Ansible. Other tools that also make that possible are Chef. Okay. Of these three, Ansible is the most common and most generally used at some not really advanced level, but maybe after 1-2 years of using Ansible, you just might find yourself in an environment where your organization will say, you know what, for this project that we are doing for Chevron, we are going to use a Chef instead of Ansible to deploy it. Everybody go and learn Chef. Because you're already very used to Ansible, it may not take you more than 2 hours or 3 hours to learn Chef and then begin to work with Chef. Over the next 2 weeks or 3 weeks, you become just as good in Chef. But they are all three are configuration management. The interviews will ask questions like, okay, what tool do you use or have you used in your configuration management? I say, I have used the Chef and the Copy just a little, but mostly in the last 2 years, I have mostly focused on Ansible. At least it gives them the idea that, oh, you know that there are other tools and you actually know their names. And they are likely to believe, okay, for you to know that this is what they do and for you to mention them at this time, you probably really do know. But since you say Ansible is your strong point, then we are going to ask you questions around Ansible. Even though we don't use Ansible here, if you're able to show that you really do understand Ansible, then we can take you in and then give you the materials to go and study so that if it's copy we are using here, then you will just learn, provided you are good in the other area. You don't have to be 100% good in everything that we ask you. If we see that you are good enough in operations, you are good enough in lineage, you are good enough in this, we just need to encourage you in this other area, then we'll bring you in. Maybe not pay you the maximum compensation for this role. Maybe instead of 150, we'll pay you 130 or we'll negotiate 130. It just means that from what you know so far, you are trainable and you are. All right, so those are the ideas about modules. There'll be more commands, of course, but whatever command it is, ChatGPT is good at telling you, oh, this is the command that I want to run. Can you convert this Linux command to Ansible module for me? So I just run it as Ansible module from my controller node. And then, of course, there are documentations everywhere. So this one, Ansible documentation. Yeah, documentation. It's just that AI has really simplified things, so we hardly go directly to documentation, but they are still there. They are still there. So for Ansible, I should have a link to documentation. Yes, so Ansible, there are links. And then you can read more about this other topics, which you do not need for job because we already covered everything. But just in case you need additional information for projects that we have not covered here, this documentation will be right. Identify modules. Yeah. All right, guys. So that's all we're covering in and please note that as DevOps engineer, you know so many tools, or you should know at least a handful of tools, a bit here, a bit there. It doesn't necessarily make you Ansible expert or Jenkins expert or Docker expert, even though to varying degrees. You know some of these things 70%, some 80%, but there are other people that, depending on where, what role they find themselves repeatedly doing over the past 2 years, they may just focus and be expert in Docker only. Other people may just be experts in Ansible because that's what they do on a regular basis, and so on and so on. Right? But as a DevOps person, you cut across all of these areas. And if there are areas that are too deep for, there's a particular tool, or there are areas that are too deep for your understanding, usually amongst your team, there'll be somebody who is a subject matter expert that is knows it beyond and above what an average person knows, and they will characterize it. Just like you are expected to know at least one thing better and deeper than everyone else, and therefore you may be the subject matter expert on that particular topic relative to what your other colleagues do. So what that area will be will depend on what project you are handling. You are all in a DevOps class now, but in another 2 years, maybe even in 6 months, you just might find that some people are biased because of the nature of the work that they do on a regular basis towards one part of DevOps engineering than the other part. And therefore, 1 year down the line, even though you all started as DevOps engineer, some people may be focusing on Kubernetes, other people may be focusing on Git, just running Git command. That's their focus. Other people may be focusing on automation, CI/CD automation using YAML, and so on and so forth. Right? Well, at this level, we just want to cover everything so that irrespective of where the opportunities are coming from, you are prepared. They ask you a question from here. Yes, I do. Yeah. We are able to do it. So far, that is what we have achieved. This is not the end of it. By the way, this is not the end of DevOps. We still have DevOps2. If you can afford it and you have the time and you have the interest, it's definitely a big plus to go all the way, complete that, and then you are ready for the job market. And then that puts you in a very comfortable position to be able to compete with other trainees from other trainers, and then compete favorably generally in the market, because competition is hard there. So if employers are looking for DevOps engineers and they find DevOps engineers who know Kubernetes compared to another DevOps engineer who does not know Kubernetes, they definitely will prefer to go with the one who knows more, who has done more coding. So for the competition and to be open to more opportunities out there, you want to learn as much as you can to fit into as many roles out there. All right, so that is it. That is it. All of these other ones, they are just additional material that I do not want to throw away, so I just so what I might do after this class is to try that localhost again and find out what we're not doing right. Then once I find it, I'll update the note with it, and then I'll put this latest note, this updated note. I will upload it to the Google Drive, replace the existing one so that you have the latest. Reference it in your app. Any questions? Any questions? So for next Wednesday, I do not really have a topic to cover. So it will just purely be what you bring to class. What you bring to class. If you bring projects, if you bring issues, you bring anything that you could not solve on your own, that's what we will do. And for formal class, today we are doing this.
What will be the scope of coverage for our next class, DevOps 2?
For DevOps 2, let's look at that. DevOps. For DevOps 2, the DevOps 2 will be talking about Kubernetes. Yes, we're talking about Kubernetes clusters and how we are going to replace Docker, not really replace, how we are going to expand our knowledge of Docker and Ansible to Kubernetes. We'll explain Kubernetes concept, we'll talk about the components, and then we'll do the primitive. We try to install by ourselves imaginary on-prem environment, a Kubernetes cluster using what we call kubeadm. Right? This is local, cannot be trusted for modern day operation, but we'll learn it anyway. And then after that, we'll now learn the more common way of deploying Kubernetes these days, which is managed Kubernetes in, cloud provider managed Kubernetes, in Azure, in Google Cloud Platform, and especially in AWS. We'll set up that many times, and then we'll use it to do all of our classroom practice of how Kubernetes works. And then ultimately, the big deal, after we have understood Kubernetes, we're able to build deployment, build service, build a 3-tier application with front end, back end, and then we run all of our YAMLs, everything is fine. The goal here is to be able to use Terraform to build production grade Kubernetes cluster. This is the big deal, climate, ultimate for this, the ultimate project for the whole of DevOps. Method 3, production grade EKS Kubernetes cluster. All right, so we are going to refer to this. This is not a one-man project. This is taken from the real-life production environment. And then we use, whereas previously we have been using just main.tf to create our infrastructure. Under this EKS creation and deployment, our Kubernetes cluster will be created using a combination of at least 10 different files. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are going to see how do you use 11 different Terraform files to create. That tells you we're not talking about a small environment. We're talking about big production grade environment. Or we are creating backend for our Terraform state files. We're not just working with Docker Hub, we are creating Elastic Container Register within AWS, where we'll upload our image to. We'll create EKS cluster, that is Amazon managed Kubernetes cluster, and so on and so forth. And then ultimately, having created that robust infrastructure, Kubernetes infrastructure, we'll now deploy a sample application into that infrastructure. It's a big project. So that's what, and then once we cover that in DevOps 2, then we are done. The only additional thing we just do on top of that is install Kubernetes and Grafana as our monitoring tool. You know how that works. Then we'll see how we use that. And then basically we set that up. It's not really our work to configure it. Configuration is something else, but we set it up and then we just use it to have a glimpse into what is happening inside our Kubernetes cluster, how much resources our application using and so on and so forth. So after all of that, then you are now ready, especially with this project. Once you have this project, you're able to deploy this project, then this is the only, well, even if this was the only project that you always have in your head all the time, then you are now able to pass. You should be able to pass any. So every time they ask, yeah, can you share project with me? This is where you'll be sharing from. But this is not just classroom work. This is production environment work. All right, so that is the scope of the project. DevOps is completely focused on A to Z on Kubernetes. Kubernetes is an upgrade of Docker and Ansible. All right, that answers the question.
Yeah. I thought in the previous class, I thought you mentioned doing a project that included a 3-tier application, since all we've been doing now has been a 1-tier.
Yes. Yes, I mentioned it here. Or what did you, that you would do it in that class? Yes, I
Or is it for
here.
DevOps2 class or is
Yes.
DevOps1?
This is DevOps2. That's for Kubernetes.
Okay.
It's deployed in Kubernetes. Yes, we saw it here, Justin. Somewhere. Yeah, it's in DevOps. Oh, 3. Yeah. Yeah, this is it. It's just there's really no big deal, to be honest. It's just the code that already integrates the 3 tier, right? And then we are calling it from Microsoft Container Registry. Right? And then we are already using a small database called Redis, not like a big one. So you just have a feel of part of the experiences you need to be able to convince the interviewer that yes, you have worked at. Okay. Yeah, we'll deploy. Look at the code. Create namespace. Yes. What is this Kubernetes command? kubectl get nodes, kubectl get port. And then in future, don't worry about it. Yes, so that's it. Any question? Any more questions? So at the first level of your interview, once the recruiter calls to say, I saw your resume, and then this is what they typically would expect. This is what you should know to be able to get your way through the preliminary level, the recruitment question level. So once you understand this high level workflow of DevOps, then it should be good enough to pass the preliminary interview and get yourself into the technical interview. Right? So I love that. So that one is just about, okay, all of the tools that you claim you know, how do they all come together? How does Jenkins work with Maven? Produce artifact? What do you do with the artifact? How is the artifact converted? So once you put all of that together, maybe something, not necessarily memorized, but something that you should, like a one-page document, you should really get used to. So that when they ask a question, you just use that as a high-level explanation, and then they can now deep dive into, okay, I see you have used this, I see you know this. Can you tell me more about what you did with this? What project did you accomplish with this? And you can deep dive. But if you're not even able to coordinate all of the terminologies together to form a picture of this is my understanding of DevOps based on the work that I've done so far in my 1 year, 2 years experience, then you may not even get the chance for them to ask you the questions in your work. So the workflow should make sense from developers writing codes using Java or Node.js, and then you coming in to use Maven to build the codes into Artifact and using Jenkins to automate the process. You see how I'm mentioning the names and relating them together now. And then from there, they want to save the codes into, your artifact repository like default. But typically, you build the artifact into images using the Docker file and your artifact. Things like Docker build, and then Docker run to pull the image from your image registry and deploy them to your operations. The operations, depending on the project, could be simply Docker. Sometimes it's Ansible, but these days, most commonly is Kubernetes. And then they are picking this, oh, you know Ansible, okay. So they are putting all of these points down. They are coming back to you later on to say, okay, can you give me a typical example of where you deployed this to Kubernetes, for example? What did you do? And that gives you the opportunity to share some of the projects. It's about Docker. Oh, that's simple. I just Docker run, Docker build, Docker run, and then I save the image to my image repository. What image repository are you talking about? What containerization do you use? Oh, I use Docker Hub most commonly, but I also use ECR, which is the managed container registry in Amazon. I use ACR, managed container registry in Azure, and then these days I also use MCR, Microsoft Container Registry. So these are places where organizations will save their repository for privacy and confidentiality. Occasionally, I also use Docker Hub, which is important. Just once everything you are saying is making sense, no ambiguity, everything is clear. Even somebody who is a complete novice is making sense. Yeah, you are making progress. Then occasionally, when they need to hear technical terms, you use them. No, not occasionally. They always need to hear technical terms. I mean, when they ask you specifics relating to technical terms, then you also explain it in ways that you would understand. That's it. And then one more thing, all of these projects that you are building, make sure you have them somewhere, at least in your ID, or prefer. You see how these projects are arranged. There's no, like I saw CoSysO one time. There's no way somebody will see all of that project arranged and prove that you actually did some work by yourself from the commands that they see here, that they will not give you a chance. Say, you understand this thing enough. Unless you are claiming 7 years experience. You are claiming the moderate 3-4 years experience, and from what? So occasionally they may want to say, okay, show me what you have done. I understand everything you have explained, but there's something you can show us to just prove that this is not theory, that you've actually done something. It could be from here. Mostly it should be from here. And then it could be also from your GitHub. But for me, GitHub is not convincing enough. You could just take somebody else's work and show me here. So how do I know that all of this? So I want to see the relationship between the GitHub repository here and your work here. I want to see, oh, okay, this is where you did the work, and then ultimately push there. And I can just look around without even you typing. But I want you to type something, type a command just for me to know that you know how to type. I want to see your speed of typing, your error. I know you are nervous while you are working. So these are the things that I'll put together to say, this guy knows what he's doing. Let's give him it. Or I feel that everything he showed us was made up. I'm not convinced that he did all of this for months. So that's what we call portfolio. Whatever project you are building, without making them too obvious that for training, there's a way you can. Even if it's training and you know what you are doing, there's nothing bad. Everybody trains. To say that your company's work is confidential, you are not allowed to share. So therefore, you deliberately set up this environment so that you can demonstrate. You don't want to share confidential information of your organization. Yes, those are tips for you. And then, yes, let's go ahead. I mean, it's not a matter of if, unless money is the problem. And because for yourself now, we are going ahead at the current rate. Let's go ahead, and then we'll just continue the training from March 4. So the training continues, no break, March 4. And then we'll start DevOps 2. Same period, Mondays, same time, Mondays and Wednesdays. And then once I'm done with you, you'll be the last class I'm teaching DevOps 2 under this old fee, the new fee on the website. And by the way, if you are registering, you'll not be able to make payment on the website because the new fee on the website is $1,000 for DevOps1 and 2. So it will be links outside of the website for you. So let's continue, then we'll go all the way to DevOps 2.
Did you say you're not taking DevOps after this after the next one again? Is that what you said?
No, I mean I'm not the curriculum, the fee, especially the fee, will be different. So I'm not taking under the same condition. That's what I said. The training will go on, even though emphasis is going, but not. The website is reflecting a different fee.
Okay.
Mr. Akin, I don't know. Have you heard anything about the platform engineering?
Yes. Yes. So
I was having a discussion with a friend and he mentioned, I don't know if you can, but he wasn't technical enough as to explain. I don't know if you can throw more light.
Yes. So right now, what we are doing is we are going for all of these tools that we have used so far. Have you noticed that we go here, pick Maven, we go there, pick Java, we go here, pick that tool. So we're just all over the place. Pick a tool there, pick another tool here, pick another tool here, install, and then we install all of them together, and then we form, right? From Maven to Java but in platform engineering, all of the tools would have been arranged by current DevOps engineers and other service providers. So you don't need to go here, go look for tool, go here, go integrate GitHub, go here, integrate Docker Hub. All of the tools would already be arranged here, from coding all the way to operations. The tools are already in one place. So this one place where all of the tools are already arranged is called platform. And an example would be Azure. Azure already has a platform where, as a DevOps engineer, I don't need to go to GitHub to do one thing, like I was explaining, go to this one to do another thing. No, my GitHub is already here as Azure DevOps. My Docker Hub is already here as Azure ECR. All of the tools, everything is already here. Everything is already in one place. So I can build my code and host my entire code. All of the Kubernetes is already here. I'll build everything just staying within this platform without going anywhere else to go and look for open source application to come and help me do one thing or the other. Even ChatGPT, I don't need it. Everything is already integrated here and presented to me as a platform. So as a platform engineer, I would just stay here and do all my work from coding to deployment. The servers that I would need to deploy, I will not even need to create them. They're already there. Everything is there as managed services. All right, so this is the next level that DevOps engineering is going. DevOps engineering is converging, is coming to the point of don't go and look for this and bring it. Don't go and look for this and bring it. Everything is already assembled for you. Just stay here and do all of your work. That's platform engineering. So in the next 2 years or so, I expect that the name DevOps engineering will begin to fade away and it will now be replaced by the name platform engineering. It doesn't mean that the knowledge you have is useless. It just means that there are better ways of doing things than going to different places to pick to. Does it make sense?
Yes. So as a DevOps engineer, how you come in here is just that you don't have to go outside to provision. Basically the same thing. We don't have to go outside to provision or to integrate other resources.
Yes.
Everything is just within one scope, just like
Exactly.
Microsoft Teams and SharePoint.
Exactly. Exactly.
Okay.
And then GitLab, yeah, I think it's GitLab. It's also trying to do the same thing. So you don't have to go somewhere, bring this, go somewhere else, bring this. That's essentially what we're doing now. This one will soon become old. So everything that you should be going everywhere to bring is already assembled for you. And Azure is good in this. Azure is good in this. From the past.
Is Azure the only this thing that is heading this kind of a
No. There
now?
are many. There are many. So the Azure part of this is Azure DevOps.
Okay.
So Azure is just popular because it's a big market, it's cloud provider. There are other smaller platforms that would customize according to the need of the particular industry, but they are not so popular yet. Unless I work for hospitals, for example, I may not know the platform unless I interact with somebody who works there that is popular for hospital. What's their standard called? HIPAA. So depending on the regulations that is governing the industry, there are different platforms that are already customized, that once you are working there, you don't even need to worry about the compliance with cybersecurity frameworks. Everything is already in customized. Just start to work. So at the end of the day, doing DevOps engineering will just look like you are writing Microsoft Word. Like you said, like you are using Team, you are using because everything you need is just a matter of click it. And then another thing I see is that DevOps engineering would also feed in the sense that the part of coding that we keep referring to will now ultimately merge into, so DevOps is development and operations. So instead of that separation, everything now merge together. So once they merge together, then it's likely that the name will change from DevOps. So the same person will do coding and then use all of these tools to build the code into operations. So there's no longer separation between coding and operations because all of the tools are in one place. Just go and learn to use this platform and then you'll be able to do everything. So that may take 5-7 years. I mean, by estimate, it could be shorter, but ultimately, one person is now responsible for everything instead of the current division between development and operations. It will now just be one, but it becomes easier and easier and easier. All of the tools are now presented in one place. Even ChatGPT alone has made it so easy that even if you don't know how to write codes, once I put some AI tool here that can provide the codes for you, then you just write the AI will simply write the codes for you, and then you as the DevOps engineer will just complete the part that you already know, and everything will just go live. And then you just click somewhere here, the URL, and it will browse, and you just see the work that you have done. You just come here every time you want to improve on your website, for example. Let's call it website. It's actually web application. You just come here and improve on it. So one person can actually do it because all of the tools that made it difficult earlier on for one person to do would have been provided, including an AI that is guiding you, literally taking your hand and leading you.
I feel like it sounds small scale, though. I feel like it will be a problem for enterprise applications, especially for all those big companies. But, I mean, in the foreseeable future, if it was small, just within maybe a small distance, it wouldn't be bad. But big enterprises, imagine someone doing that whole job for Facebook or one of these big companies.
Okay, maybe actually when I say one person doing it, no. What I meant was actually using one interface to do it, not really one person.
Okay, that makes
using
sense.
one interface to do it, but multiple people working with on this interface. But yeah, I mean, that's essentially what it is. We don't really know what the future is. We are just predicting and seeing what we see. But for now, what we do know is that all of the different tools are being assembled in one place and made available as a single tool. That single tool is the platform.
Okay, thank you for the explanation.
Yeah. All right, guys. So if you have anything that you should prepare for against Wednesday, please mention it before Wednesday so we can look at it. Otherwise, we just come to class and then I hear you out. You ask questions like you did now. And if we have enough questions to keep us busy all through the 3 hours, fine. Otherwise, we just do as many minutes or hours as we are busy for on that. Thank you, guys. We'll see you on Wednesday. Everyone.
Good night.
Bye-bye.
Yeah.
All right.